this is a picture in your textbook. It's figure 3.3, and I just want to amplify it a little bit. So we've got the homosphere. Notice it's the stuff that all has the same blend down here, right down here. And comparative height to the heterosphere, it's a lot shorter. I know we think 80 kilometers is a big number, but look, the heterosphere goes, look at the picture way at the top right, 1,500 miles up. Okay, so everything I've marked with the red arrow, that's the heterosphere, and everything down below is the homosphere. Right? Now, way over on the right-hand side, here's what we mean by homosphere. Okay, the air blend is in this area is all 78% nitrogen, 21% oxygen, and 1% other. That stuff we looked at last lesson, that blend. Now, once you get up above the homosphere into the heterosphere, guess what? There's a chunk that's predominantly oxygen. There's a chunk that's predominantly helium. And then everything above that is predominantly hydrogen. Okay? So within the homosphere, everything is this nice 78% nitrogen, 21% oxygen, 1% other. You go above that, and then you got chunks that are distinct and different from each other. So for now, let's focus it in on this lowest layer, this homosphere. Okay, we're going to jump into this piece right here. Well, guess what? Within the homosphere, there are layers, or since we're talking about the globe, there are spheres. So I'm going to take you on a tour of those spheres within the homosphere. Okay, and this is figure 3.5 on page 65 in your textbook, if you're following along with the textbook. Okay, so the uppermost layer of the homosphere, okay, is called the mesosphere. Okay, and mesosphere begins with an M. Meteorites begins with an M. This is where most meteorites, if they get inside the atmosphere, will light up due to friction and burn up and be done. So that's the mesosphere. Below the mesosphere, okay, and I've got it called out here with this gold arrow, is what's known as the stratosphere. Okay. Now, if you look at the picture, you'll see there's a few airplanes that get up in there. Okay. You'll also notice that there's, in the middle of the picture, there's from 20 kilometers to 30 kilometers, there's the ozone layer. And we talked a little bit about that last lesson. We're going to spend a little more time on it this lesson. But that's where the ozone layer is. And it's nice that God put it way up there so it can protect us from all that UV stuff, but as we learned last lesson, it's kind of fatal to us. So it's way above where we're hanging out. Oh, maybe you've heard of when they when the weatherman talks about the weather, he's talked about, well, the jet stream today is okay. This is where the jet stream does its thing, up in this layer in the stratosphere. Which I got to tell a story. There was one time I had to go on a business trip from here in Texas up to San Francisco, California. And what was interesting, the way the jet stream was making the path of the jet stream that day, it was providing basically a 300 mile per hour headwind for our flight. Now, without wind, airplanes, typical commercial jetliners are up around 500, a little over 500 miles an hour. Well, if you've got a 300 mile an hour headwind, you're actually only going 200 miles an hour, which means you're still burning the same amount of gas, but you're not covering the same amount of distance. So we actually ended up flying from here in Houston landing in West Texas, okay, staying in Texas after flying for 2 hours, landed, refueled, and then finished the flight to California. So these winds, okay, can make a big difference. All right, we talked about the ozone layer. Oh, another flight I went on. Flew from New York City to Singapore by going east and north up over, basically over the North Pole and then down across all the stands, what I call all the stands, Kazakhstan, Afghanistan, Uzbekistan, Kyrgyzstan, and then down across India and landed. We took off, and because we had so much gas, we started flying at 37,000 feet above sea level. And as we burned off gas, we got lighter and we were able to get up higher and ended up, before we landed, we were as high as 41,000 feet above sea level. So we were up there in the stratosphere. We were zipping along. Now, and I'm going to spend a little more time on this in a little bit, but here's a weird thing that happens in the stratosphere. Normally, the higher you go, the colder it gets. In the stratosphere, and I'll explain why, the higher you get, the warmer it gets, which is really interesting, but we'll get to that here in a minute.